Hi everyone. Today we will be presenting on the effectiveness of different concentrations of T4r bacteriophages in killing E. coli bacteria cells. I'm Shravan, and
Sasan.
ever since the discovery of antibiotics in the 20th century, they've been the go-to medication against bacterial infections. However, with the overuse of antibiotics, bacterial resistance formed, and now scientists are looking for different alternatives for antibiotics. In our experiment, we tested phage therapy in which bacteriophages, such as in our experiment, T4 and T4r, would kill bacteria cells. Our test subject was E. coli B. We chose it because it is a harmless gram-negative bacteria cell which is capable of bacterial conjugation, wherein the cell can develop resistance.
So plaques are circular spots of dead bacteria formed when bacterial lice been attacked by bacteriophages. By analyzing them, we can see how effective phages are. Our hypothesis is also on the screen. So we tested 5 concentrations of bacteriophages with 6 trials for each one. You can see a list of our materials on the slide. So in our procedure, we first melted the tryptone base layer and filled the petri dishes to a depth of 5 millimeters. We then labeled 5 tubes of soft agar, melted the broth, and performed 2 1:9 serial dilutions to get 10 to the second and 10 to the fourth particles per milliliter concentration. Lastly, we inoculated the petri dishes with phage and bacteria. The plaques formed 4 days after the inoculation and were characterized by transparent spots. We used dark field microscopy with a dark field condenser lens to see the plaques, and then we counted them using the plate graph approximation technique. Our safety slides can be seen on this screen and our data is on this screen. So to prove our hypothesis, we first had to run a few statistical t-tests to reject the null hypothesis. In this regard, we carried out 4 t-tests as seen on the screen. With an increase of bacteriophages, we hypothesized that there would be more plaques and fewer bacterial colonies.
In our first t-test, we observed an increase in plaque counts for an increase in phage count. The data gathered was put through a linear regression t-test with the null hypothesis H not equal to 0 and the alternative hypothesis HA greater than 0. The p-value was extremely low for both T4 and T4r phages, and so we could reject our null hypothesis. In test 3, the bacterial colony count decreased for an increase in phage count. However, in this test, the p-value was slightly higher than the threshold value for rejecting the null hypothesis. For T4, we would have an 80% confidence, and for T4r, we would have a 92% confidence. This could simply mean we needed more data to better prove our trend and thus reject the null hypothesis.
So our discussion, like p-values can be seen on this screen. So our null hypothesis was mostly rejected. And so, according to a study by Brian et al. In 2016, the tryptone agar base layer proved to be the most optimal environment for the T4 phages to travel through and kill bacteria. Our experiment corroborates this finding, as well as difference in morphology between T4 and T4 phages. As expected in low-budget experiments, we did have some errors and outliers. 2 plates with no phage inoculated still produced plaques, which surprised us. And some plates had fewer than expected bacterial colony count, which could be related to the density of the tryptone agar base.
If we were to conduct this experiment again, we would make a few changes to our experimental procedure, like more sets of data, different concentrations of phage, and also more trials in each set of data, which can help us strengthen our trend. The impacts of this project are very vast. First of all, antibiotic resistance is extremely important, and we must find a solution. Phage therapy can help kill such dangerous bacteria cells, and it is a really good alternative. And you can see a few future studies on our screen. So these are our references, and this is a picture of our experimental setup and a few examples of Petri dishes. Thank you for your
Thank you.
attention.